Hello dear viewers, today I'm gonna teach you about another very interesting physics formula which is personally not very well known, but when it comes to some things like telescopes and microscopes, this formula is very used in order to find the magnification of the system of lenses that is formed. So what is the formula? First let me write. Please do ignore if I make this symbol wrong, but it's something like that. So what I mean to say is that this the magnification of the system is equal to the magnification of the first lens, the second lens, and so on till the nth lens. So now you might ask me, bro, how do you prove this? Like, yeah, it was quite confusing when I first encountered it. Let me prove it to you. First, we'll try to make this hold an equality by using two lenses. So let's suppose you have two lenses. First, we are going to take two convex lenses. In this formula, it doesn't matter the distance between them, but still we are going to consider it's d. Okay. Perfect. Now this is the principal axis. Okay. Let's suppose an object is kept here. We will call this u. It's the initial object. Now, if you remember correctly, two rays will follow, and then they'll make an image here. Let's suppose this is, for the current timing, we'll consider this as v1. Okay. Now this v1, at this v1 acts as an object to this second lens. Let me show you how. Just continue the rays further and you'll see it. We are going to take these points as these are the axis, and then here you. Now this is u2, the length of the second object. Last but not the least, as here was the image, that means that this will be v. We are going to consider this as a final v because this is the final object. This is the final image which we want from this system. Please don't mind the background noises. Now let's do the maths, because maths is the most important thing here. So what is the formula of this, the magnification of this net system? It's ms equals to, which we consider v upon u. Now you might say, how are we gonna get this thing from this thing? According to this formula, the magnification of this system should be but we are getting this. So how do we proceed? First of all, what can you write this V as? If you remember, M2 was V upon U2. Let me write it. Oh yeah, another thing. But there's also another thing. If we are not taking a point object, then we can also say image length upon object length. Now that means I can write this as the okay. Now I hope you understand, even though I've taken a point object, but yeah, this is true too. Let's suppose we had a line object. Now tell me one thing. If you remember correctly, the image formed by this point object was the object for the second lens. That means that I can say that this should be magnification of the second lens multiplied by the object length of the first object length for the second lens, which I'll say as capital O2 upon U. I should say O1 makes perfect sense. Let's say it's O1. Now part 2. What is O2? O2 is equal to I1. So furthermore, if O2 is I1, that means that I can write MS, the magnification of the system, as M2 into M2 into I1, the length of the image made by the first lens, upon object length O1. And image length upon object length is indeed the magnification. That means that the magnification of this whole system is indeed magnification of the first lens multiplied by the magnification of the second lens. Hence we have proved this. But you might say that, oh, this is just 2 lenses. What if they are n lenses? Let me tell you about 10 lenses. Now this will be real fun. And yeah, let's say we have let's say we have 10 lenses. 10. I'm not gonna draw 10 of them, but I'm gonna shortcut till 10. Okay. Bruh. Sorry for this crappy drawing that I made. But I was just trying to draw lenses after all. So please don't mind. Now, what would you assume the net magnification to be? According to the formula, it should be M1 into M2 into M3 and so on till M10. Okay. So on, it should be till M10. But how are you going to prove this? You might ask me. Well, let's do the previous approach. If it holds equality for the second case too, then that means that the formula which I showed before, nth product of magnification results in the system magnification, is true for n number of lenses. Let's get started. So what is MS? Again, V10 upon U10, which I can again write as O10 upon I10 upon U1 O1. I just get confused in the symbols, but I hope that you get it. That the magnification of this entire system of lenses, if it was just one lens, if was just one lens, then I could have said that the magnification of this lens should be equal to the magnification of the system, and also the magnification of this lens is written as the image length made by this lens upon the object length which I had put in front of this lens. Okay, now let's break it. I10 upon O1. What is I10? M10 into I9 or O10. After all, the image formed by the previous lens is the object for the next lens. So I can say it should be either I9 or O10, but we have upon O1. Now you might ask me, okay, I9 upon O1, still it doesn't come out to be this thing. Okay, yeah. Now let's do the bifurcation infinitely till we reach to the point that we are almost done. So now, as I've already told you, that the image formed by an object can be written as magnification of that lens multiplied by the object length. So from here we can say MS should be equal to M10 into M9 into M8 into M7 into M6 into M5 into M4 into M3 into M2 and finally into M1. And as you know, it has come from this formula. We just proved it. I hope that you understand it, and don't worry, this thing applies to the image length too. Image distances too, so don't fear about it. You just need to multiply all the magnifications of the lenses in the system, and thus you'll get the net magnification. After which, if you are told to assume that the system is one lens, then you can just take the magnification out and every other thing that has been asked. Thank you for watching this video, and subscribe to me for more informative videos. Thank you.